Welcome to this panel session on IPUs and DPUs and all related topics. I'm Bruce Davie, the General Chair of this P4 workshop, and I'm joined today by an all-star panel of IPU and DPU experts representing really most of the major players in the industry. So I'll just run through, quickly introduce everybody. From Intel, I have Brad Burres, an Intel fellow. From Pensando, who I think of as one of the companies that got this topic on the map. We have Krishna Doddapaneni, the VP of software development for Pensando. From Xilinx and now AMD, we have Gordon Brebner, an old buddy of mine who I used to play cricket with back in Edinburgh in the 1980s somewhere, and Matty Kadosh, principal architect from Nvidia. So I have a great discussion here. What are we going to do to kick things off is I'm just going to ask each panelist to give a very quick view on why they think the IPU and DPU space has really taken off in the last couple of years. And I think that's my position, at least, is that, we've had some kind of accelerators for offloading some functions from CPUs for a long time, but this particular category of accelerating the infrastructure functions that we find in modern data centers, that seems to have really taken off in the last couple of years. So I'm just going to go around the panel and you can say a few words, and maybe I'll start with Brad from Intel.
Sure. Thanks, Bruce. Yeah, I agree with you. It's definitely taken off a lot. I think it's really driven by a couple things. I think first, the need to separate the tenant workloads and the infrastructure workloads, I think, has really driven that explosion. That was one of the fundamental drivers in really getting to sort of like bare metal type deployments. I also think performance has been there, right? So, when we're running at 10 gigs, the number of cores it took to provide these infrastructure services was maybe bearable. As you move to 100 gigs and 200 gigs, that cost, increases. And if you want to scale up and do more packets or do more IOPS or whatever else, I want to do that in a much more optimized way. And I want to do that with, maybe, cores that are better optimized for the workload. I want to do that with more hardware acceleration. And so I think that's really, those two things, that separation and security you get, and then that need to optimize to deliver the performance you want, I think are the two big drivers here.
Yeah, great. Maybe I'll jump to Krishna. As I said, I think of Pensando as having been really early in this space. In my mind, at least, one of the first companies to show us that you could do something with P4 that wasn't just build a switch. So maybe you could give us your perspective, which perhaps goes back a little bit further.
Yeah, so I think, I agree with whatever Brad said, why the market took off. But in general, right, I little bit disagree that it's the last 12 months or that's when the IPU, DPU took off.
For sure, it seems longer to you.
Yeah, it has been 4 years for us. I think, if you look at the cloud providers, right, AWS Nitro or the Azure FPGA solution for VFP, GFT, you could argue, they're early forms of DPUs and they have been there for more than 5 years. But definitely in the last couple of years, DPUs have been shipping in volumes in hundreds of Ks, and DPUs have a maturing software stack that can be provided to multiple public cloud providers. That definitely helps. And even the ASICs, all the vendors are in second or third generation. That kind of helps the market creation in some sense. But I think from the why the DPU is useful, I think I completely agree with Brad. With respect to VM container workloads, the cloud providers want to monetize 100% of the CPUs, and they don't want any cache or memory interference by doing IaaS policies like encryption, compression, and security policy stuff. And bare metal, obviously the end user owns the whole x86 server, and there's no other place you can do the SDN and storage services. And in general, I would say DPU gives a better security posture for bare metal, even in the case of hypervisor, because of the hypervisor breakthrough, you're making sure nothing goes into the cloud network unless it's tested by the security policies of the DPU. That's what I would say.
Yeah, and that's an interesting point there, that I think there is this whole security angle to it as well. And this was something Nick McEwen pointed out to me, that was how, that very strong isolation is one of the things that the DPU brings to the table. Matty, let's jump to you. By the way, thanks for joining us at an awkward hour from coming from Israel. And maybe you could give us your perspective from where you see it at Nvidia.
So first, I must agree with two of my colleagues here, Brad and Krishna, that isolating the workload, the infrastructure from the tenant is most likely the strongest driver for that initiative. And I do agree with Krishna that we see that movement much earlier than the last 12 months. Cloud provider did that a while ago. We are maybe what we see now is the commoditization of that. Like we see it more and more common, and maybe moving from the ISP to others arena as well. Another area which I would like to add is HPC and supercomputer. There, what we can see that what we call the compute unit is now become a data center. Actually, you can refer to a computer as a set of data center and IO there, and whether it is storage or communication, things like RDMA, other collective operation becomes bottleneck. And we see the need there to accelerate those workload, whether is it better transport, improve congestion control, improve storage access, and so on. And for those things, DPU is great.
Yeah, so there's a kind of a lot of breadth to it there. And I have more things I want to ask you, but I want to jump over and let Gordon get a word in first. Gordon, you come to us from Xilinx, now part of AMD. Do you have a different perspective from what we've already heard?
Yeah. As Bruce says, I've been an AMDer for a few months now since Xilinx joined AMD. But yeah, I've been working on P4 compilation for FPGAs since the dawn of P4, in fact. And for us, that's always been in the kind of NIC context rather than a switch context. I think maybe being a provocative answer to Bruce's lineup question, I'd maybe say that DPU and IPU terms are kind of recent in the last year or two, especially IPU. But those of us who labor in the smart NIC space, smart NIC, IPU, DPU are all in a similar vein. For me, I like DPU actually as a term, but I also like the N and NIC for networking. And I think there's P4 people here at the workshop and networking people. I never want to forget, for me, the network interface and what's happening at the network interface is the critical thing for these XPUs, whatever we call them. So I think one side of the picture, which we've heard from the others, is about the balance between the CPU and offloading functions and infrastructure functions. But for me, the main driver, an interesting thing in this space is being reactive and kind of low latency and the network interface. And then for me, the CPU is, maybe I shouldn't say this as an AMD, the CPU is a kind of secondary factor to view. So that just as a background, and one thing I'd certainly agree with Matty said is you're looking at high performance computing. That's definitely a very interesting area. Apart from the standard data center stuff, treating supercomputers as more like data centers is definitely an important trend.
Yeah, and in some sense, it can't be that controversial to say that the CPU is not where all the action is sitting at AMD, because why did AMD acquire Xilinx and Pensando, right? They're obviously recognizing the necessity of expanding beyond the CPU. And I guess I should really stand corrected that I didn't mean to imply this was just something that sort of popped into somebody's head in the last 12 months, but rather that it's become the focus of attention in the last 12 months. That in my mind. The other really early entrant in this is somebody not represented here today, which would be the Annapurna Labs work that led to AWS Nitro. Clearly that was initially, I think people viewed that as sort of a smart NIC. But I think as we've seen, and as Gordon said, there's a bit of a spectrum where you start by moving more functions onto the NIC, and before you realize it, you've gone from a smart NIC to a DPU. and the one view of the world, at least, is that there's really a spectrum from fixed function NICs to smart NICs to DPUs. It's just the kind of logical extension. But I think for me, the sort of big jump in my mind from smart NIC to DPU was this kind of, I'm really creating a strong separation, that smart NICs felt kind of incremental on fixed function NICs, whereas DPUs were like, no, now we're actually dedicating specialized hardware for the infrastructure functions. I guess I was thinking, Matty, I assume that you've had experience with the smart NIC end of the world too. So do you see that as the right way to look at it? As it's kind of this logical growth from smart NIC through to DPU?
Yeah, I tend to agree. I tend to agree. Again, for me, smart NIC kind of is a vague definition. But if we are referring to the fact that the DPU, in addition to the NIC and the smart NIC capability, contain an entity that can run control plane, like a CPU that can run control plane and other workloads, then I totally agree that this is the trend that we see, and this is really what we believe we'll see more and more in the future.
Yeah. And I guess I'll open it up to anybody who wants to jump in. I sort of view this, again, it's sort of got a lot of traction in the last 12 months. Have we reached sort of peak DPU, or is this just the beginning? Are we about to see a whole new expansion into a new area of business?
Can I jump in? I think we're just at the beginning, right? I think we're on the first wave of what is the right thing to move down, but I think what we think of as infrastructure is continuing to change, right? Is the service bus infrastructure, is that going to completely move into your DPU IPU socket? I think that's going to continue to evolve, and since the IPU becomes sort of the place to stand for the infrastructure provider, anything they want to deploy might move there, and so I think that's really exciting to be at the sort of the entrance of this new computing paradigm for the cloud. And I also think you're going to see, cloud started this, but I think we'll see enterprise and edge, follow fast, and that becomes interesting too, because that'll have new emerging use cases to come along with it.
I mean, I also jump in. I agree with Brad. I think this is in the beginning, but I mean, right now you see, the DPUs have been already widely deployed for SDN deployments right now, right? All clouds, primarily, you can take, 4 out of 5 public clouds are deploying a DPU for SDN. And slowly, you'll see, I think already Nitro did the NVMe-based storage virtualization. You'll see more DPUs getting deployed for storage use cases end of this year and next year. And also, like, varied markets, right? What infrastructure is changing. If you look at the Azure's initiative of Dash, where they're calling this concept of SDN disaggregation, where you're putting a bunch of DPUs together as a pool, it will be better from TCO with respect to cost and power, and also solves the stranding of resources. When I say resources here, SDN processing resources. So that is an interesting thing that will also evolve. And in general, I think, all the networking services which move from dedicated x86 appliances, like the VPN gateways, and things like that are there in cloud providers, will slowly move to DPUs. And it'll be more interesting research thing, especially if we're talking to networking folks, right? Like congestion management, some earlier Matty brought it up, right? So those are like really interesting things that you can do with DPU that you couldn't do before. You can experiment those things in live clouds using the DPU. That's what I think the market will evolve to.
And I think you've both touched on something that's interesting from my perspective, that we saw the early adoption of this in the hyperscalers. Publicly, we know about what AWS has done. We've had Intel talking about what they've done with Google. I think you've already mentioned Azure as well. So it's clear that like the big hyperscalers are all going down this path, and they are the sort of 800-pound gorillas when it comes to providing these cloud services. But is there an opportunity for this to become more mainstream? Does it move into a broader set of the situations and not just the kind of the half dozen big clouds?
I definitely believe this is the case. I still think that in terms of ecosystem, we are still lacking. So it's relatively hard to to integrate DPU into your system. A lot of framework and SDK are still not there mature enough to be very, very easy to integrate. P4 is one of them. Like we are as a community working on PNA, but it is not still there. And currently the solutions are not portable. So it's very hard to choose P4 where you are writing your P4 or Pensando and it won't work on Intel or Nvidia devices. When it will be there, hopefully sooner than later, then I believe that we will see it more and more into the enterprise as well.
I mean, I think enterprises, we have a lot of experience pushing this to enterprise. So I think it's slightly different what then DPU does. The problem is how you manage that, right? DPU is not like switches, which are few. I think Bruce, probably you went through with NSX, right? In some sense, you have to manage the number of servers. The scale is higher, and you have to manage the lifecycle management and telemetry of DPUs from a central place. So that's where it's a little bit different from enterprise markets. Cloud, what happens is that they have their own cloud orchestrators, and you don't even know a DPU exists. You have REST APIs for Amazon VPC or EBS. But for enterprise, it's not that easy to introduce a new operational model, a new management stack. I mean, the one good thing that's happening is Project Monterey, which all of us are working on with VMware. Hopefully that will bridge the gap, which is obviously a easier operational model for enterprise customers. And enterprise customers can, in their private data center, can get the same benefits that you can get in the public cloud providers, with whatever Brad was saying, PPS, CPS, IOPS, and whatever is there. But still, it's not that easy because enterprise customers have a little bit varied workloads, and it's a brownfield servers, and you have to manage a heterogeneous set of systems. And there's also in enterprise this friction which doesn't exist in the cloud. How do you manage this thing? Is it managed as a NIC from a server administrator perspective, or managed as a network appliance for firewall from network admin perspective, or managed as NVM initiator from storage admin? So these things, I think it'll take time to be streamlined. It's not as streamlined as it is in cloud as far as we can see.
Yeah, and I think maybe one thing I'd add there too is that it's pretty clear that in the hyperscalers they're sort of very, very focused on squeezing out the last few cycles and maximizing the ability to monetize their processor cores, which kind of argues in favor of moving things out to a dedicated offload. Whereas in enterprise, it's common to find servers running at quite low utilization, and the focus is much more on operational ease rather than the maximal efficiency of every server. So clearly, we always tend to see things trickle down from the big clouds to the enterprises, but I think there's a couple of hurdles to get over there. And a point that came up a couple of times now is sort of the tooling and making that part of it easy. And I think this is probably really important for this audience, that P4 is quite central to many of these devices, maybe not all of them, but it was, I think, Pensando who I saw first with a P4 based capability inside the DPU, and then similarly with Intel's Mount Evans, leveraging some of the barefoot technology. So we've seen P4 showing up in these devices, which is one part of making them kind of more consumable. So like, what do you folks think about where the industry needs to go in terms of making these things easier to use and providing the right programming environments? And is P4 the long-term trend here?
I agree with what Matty said about.
Well, everybody's got an answer. Maybe I'll let Gordon get a word in. You've been pretty quiet.
Yeah. I was just going to say, I've been involved in P4 since the beginning, and I think this is going to be a shot in the arm for P4, because the original model was P4 is for switches, and a few people make P4 programmable switches, but most people can't get their hands on switches. And I think now we're at the kind of host interface, in DPU, IPU, NIC territory. It's kind of democratizing P4 almost in terms of people getting easier access, and in the enterprise, for example, if it gets down that far. I think this will be really important for P4 In p4.org, we have the portable NIC architecture initiative going on at the moment to complement the original portable switch architecture. And a lot of researchers, for example, do switches and things like that. But in real switch world, there's a limited audience for P4. But I think all the technologies, what Pensando have, Intel have, we have a P4 programmable SmartNIC as well. That there's just going to be great opportunities, not just for using P4, but for extending P4. So, for example, Pensando have interesting P4 plus extensions, which have been discussed in the PNA work group. And, there's other things on the P4 wish list, which I think are going to get accelerated, but because more people will just have access to programming in P4 and extending the programming model, because these cards are just much more accessible than tampering with the switch.
Yeah, it's an interesting perspective, isn't it? That, I think it's sort of the disconnect between researchers who all want to work on switches and sort of the real world where everybody actually needs to program their NIC. So I think that's a very nice perspective, that this could actually make P4 meaningful to a bigger community than it currently is. Brad, I think you were going to jump in before I cut everybody off.
Yeah, no, I think I was going to agree with what Matty said early on, which is, we need to develop a broader ecosystem, and there's some of it's developing with VMware in a proprietary way. And then we also need to develop much more of an open source ecosystem for these as well. And we see some of that with IPDK and with the OPI, the Open Programmable Infrastructure initiatives. Those seem super important. So I think P4 is one component of it, but there's a lot more tooling that has to happen, right? We got to, things like DPDK and SPDK and IPDK all have to land and mature. I guess like DPDK is certainly mature, but we need to get all of those in place and working across a variety of different targets. So in terms of like all the IPUs we're talking about here today, and when that happens, that's when it really explodes. That I think across the spectrum.
I mean, actually, I kind of agree with the Gordon and Brad also. I think the P4, right? I mean, P4 is a data path programmable interface, the way I look at it. Because if you look at this IaaS stack, even on the DPU today, there's data path and there is this control plane and management. It's pretty much system on a chip. It's not from ASIC perspective, a system on a chip from a networking appliance or a storage appliance point of view, right? But given said that, right, P4 is definitely the DPUs and SmartNICs are giving a shot in the arm. I completely agree with it, because there is a perfect use case for it. I mean, if you look at any cloud provider, right, so far, any production cloud provider, I did not see a place where, all of them use the same NCAP, or all of them have the same number of layers of NCAPs, or actually, there's no one way. How do you identify an interface itself? That's the simplest thing. Complicated things like, I'm not even talking about server load balancing, NAT, or how do you communicate a cloud SaaS services within the public cloud without doing an internet U-turn. So I think definitely, P4 is the interface. I think the only thing, I would say against P4 is, if you give a software engineer a choice between C and P4, I would think anybody would pick C, right? Realistically, I mean, we don't want to ignore that part, but if you look at it, right, you don't get the same performance, programmability, I mean, and from respect to latency and jitter that P4 gives you. And I think, P4, Gordon was talking about it, right? It will get extended, not just from the PISA architecture and the switch. It can be extended to writing drivers for UPT, VDPA, VirtIO, NVMe virtualization. And, what we figured out, writing P416 applications using that, right? P416 is pretty complete. Obviously, we'll do some externs and annotations, but P4 is helping us. I think other thing that's important for P4 is, I mean, I know we did P4 switches before, but if you look at switches, right, they don't change that often. The data path doesn't change that often. But if you look at the cloud IO paths, they change, in our experience, they change every 2 weeks. Okay, every 2 weeks. So when it changes, then you need a way to upgrade the P4 code path with minimal disruption. So I think P4 is helping in that operational perspective a lot.
Yeah. Yeah. I mean, this actually mirrors my experience from the network virtualization world, which is that one of the things we loved about having our virtual switch in software was we could update it, daily if we needed to. And that ability to be constantly innovating in the virtual switch was a kind of core value proposition for network virtualization. And I think you really put your finger on it there, is that, yeah, core switches shouldn't be doing all that much and therefore shouldn't change that often. But that interface between the guest workload and the cloud, that is the place where lots of things need to change. So yeah, I guess you could say the future is bright for P4 here.
If I could just throw one comment in, just because
Yeah.
I love the point you made, Krishna, is the reason cloud needs to make those changes, which wasn't obvious to me at the beginning, is they're getting new customers all the time, right? If you get a new, enterprise bank that wants to move their workload into their cloud, and all of a sudden they're like, hey, my current thing doesn't work. They gotta make the change in order to support that workload at the necessary performance. And I wasn't super clear when I started on this journey why they didn't make changes every 2 weeks, and now I get it. So.
Yeah. No, I completely agree, Brad. I mean, there's an example for cloud provider, right? Let's say I run Nginx, a simple Nginx load balancer on my enterprise data center, and I take it to cloud. You don't get the same performance. To make that happen, you have to do some P4 data path changes. That's a very good example, actually.
Yeah. Yeah. So I feel like we should maybe just do one final round to get everybody a chance to say a last word. So I'll go around the panel and just ask everybody to say, where do you see us with this IPU DPU space? Project out as far as you like, 3 years, 5 years. Where are we going to land with this? I'll start with Matty.
Sorry, I was muted. Oh, that's a big question. The place that that I would love to be in, and I will get back to my SDKs and tools for users. I would like to see us as a community building a more mature environment. Not only part of it is related to P4 and PNA, and make that support things like multi-tenancy, stateful operation, which is things that are currently lacking, and we need to define together as a community. Performance, telemetry, visibility into it, and into other areas as well, like storage and security and I/O, device emulation. Creating SDK and standard SDK and open source ones that will provide users the ability to use those entities, use those tools, and I believe it will increase the infrastructure and increase the ability of people to consume DPUs and IPUs.
Yeah, so really a maturing of the tool set, making the whole space more accessible. I bet everybody would like to have had first go at answering this question, but I'll hand over to Krishna. What would you like to add to that?
I mean, I think next 5 years, obviously, I think every public cloud provider server will have a DPU. I think that is a given. Hopefully, every enterprise server will have a DPU. I think that will be a good thing in general. And we use the CPU for applications, and we use DPU for all the IaaS services. I think what Matty was saying, whether it's SDN, storage, encryption, any of those services, I think that will be the goal that we can aim for. At the same time, right, I think I do agree that we need some SDKs, we need some APIs, but it's not an easy problem to solve, because even if you go to cloud providers, right, a VPC is different from a VNet, and a security group, which is simple, same concept. If you look at NSX versus AWS versus Azure, it's all a little bit different. There are tiny differences. So we need to come up with a way where we can normalize that so that all the customers, enterprise customers, can get on it. I think that's that'll be nice.
But you're effectively predicting world domination for DPUs. That there'll be one everywhere. It'll be as common as mix.
You're talking to the DPU vendors.
Yeah, you may have an agenda here. All right. Well, let me hand it over to Gordon.
Yeah, I mean, I think it's been said before, this is just the beginning of a long journey. The journey began, decades ago with building kind of obvious networking functions. Bruce was a pioneer in that area. Otherwise, so yeah, and it's evolved. I think the interesting thing, obviously, the challenges around software and use models will be, what's the mixture of kind of computing resources that are on these things. If it's a data processing unit, what's on there. Obviously, I've been a bit biased in the past thinking about having FPGA-based acceleration, as part of the components. And anecdotally, a few years back, I got unusual universal marketing and engineering pushback in Xilinx because I was using the term smart NAC, meaning smart network attached computing. And the idea was having the right kind of computing things directly attached to the network connection. I think we'll see more of that. That's my personal passion. It's less a pipe to the host, but doing things on its own. I think we can see all these interesting use cases and different technologies appearing on the various DPUs, IPUs, smart NICs. I think it's going to be really interesting as people explore what the right technologies are to have there, to not just offload stuff, but really to do first order work.
Yeah, so an increasingly central role there, and of course a role for FPGAs. We predict that.
Yeah, FPGAs and CPUs and GPUs, of course.
Yeah. And Brad, I guess you'd like to have everybody calling them IPUs rather than DPUs, but
well, I was going to say, I'm hoping in 5 years we agree on a name finally.
Yeah, yeah.
So I think that's we should have.
Maybe we can do better than XPU, but anyway, in all seriousness, like what else would you add in terms of your vision for the future?
Sure. I mean, I think what I expect is we'll see the continual movement of infrastructure tasks down into the IPU DPU to the point where you'll see no cycles on infrastructure running on the compute. It just becomes your business value applications. And what that means we have to do in what we're building, all of us here, is work on software-defined everything. Right? We really need to make sure we create the right framework, both in terms of the silicon building blocks, whether it be programmable hardware or cores or fixed function hardware. Right? We need to get all of that in place with the right frameworks on top of it, so that the developers can build the software-defined everything, whether that be networking or storage or other infrastructure tasks. And I do agree the lifecycle management part is going to be key to deploying that beyond some of the initial footholds we have.
Yeah. Well, look, I think this is a pretty good point to wrap it up. We've clearly got a very expansive view of the future here from people who are well positioned to see it. Maybe a few agendas being pushed here, but still, it's like this space which has become very visible in the last year or so, but has a long history going back a few years if you think from the Pensando viewpoint, or maybe even 30 years if you think from how long have we had smart NICs. But this is a long game, and it's clearly quite a significant transformation in the industry that's creating a new market where infrastructure functions no longer just get shoved into those spare cycles on the CPU, but get their own first-class infrastructure. And then I think the other common theme that I've heard come up again is, P4 is adding some value here in a way that makes it more democratized, making it perhaps more of interest to a bigger community, but that there's a lot of work still to do to create the appropriate tooling, SDKs, ecosystems, whatever. And that, I guess that's a good message for this P4 workshop is, P4 has enabled this new market to take off, but there's a lot of work to be done to actually let it develop and deliver what it could promise. So I think with that, I'll just thank all the panelists. This has been a fantastic discussion. I think it's given a lot of interesting ideas to the rest of the community, and thank you all for joining us.
Thank you.
Have a nice.
Thank you.
Thank you.